Hello, ladies and gentlemen. I'm called Emmanuel Ejo. I'm going to take you through Sparse Graph Attention Networks. Um, um, yes, welcome once again. We'll explore Sparse Graph Attention Networks. In short, you can refer to them as Sparse GATs, a key optimization in graph neural networks, GNNs, graph neural networks. We'll start by understanding basic graph neural networks and then move to graph attention networks and then discuss why sparsity is important in deep learning for graphs. So as you can see, these are some of the graphs as they become more complex, from one that has around 2 nodes to one that has multiple nodes with a lot of relations. So beginning with the GNNs, the graph neural networks, GNNs are designed to handle graph structured data. Unlike traditional deep learning models which work on images and text, GNNs operate on nodes and edges, capturing relationships between entities. Here is why we discuss GNNs first. They need to understand the context. Sparse GATs are an optimization of graph attention networks, which are a type of GNNs, or which are a type of graph neural networks. Without understanding GNNs, it's hard to grasp why sparse GATs are useful. So in order to progress the concepts, we have the graph neural networks, which are general models that process graph structured data. GATs a specialized GNN that introduces attention mechanisms. Then sparse GATs a further optimization to handle large sparse graphs efficiently. So it's important to make sparse GATs easier to understand, and that's the reason why I could not skip going through the GNN, which my colleagues have already gone through, but it helps. And the sparse GATs really look at scalability that may not be with the other GATs. What are graph attention network? GATs enhance GNNs by learning which node connections are more important using attention scores. This is especially useful in complex graphs where not all connections are equally significant. And so here you look at the benefit of weights, which weights are assigned to different nodes so that you can see the actual benefit of that. We are also going to look at the challenges or limitations in standard GATs. Despite their benefits, GATs can be inefficient. Computing attention for all edges becomes impractical for large data sets, leading to high computational and memory costs. So here you can see some of the graphs showing exponential growth of computation with increasing nodes. That means that the more the data, the more the computation power increases, and this is something that we are to look at. So in order to overcome the inefficiencies, sparse GATs optimize the attention mechanism by selecting only the most relevant node connections, hence reducing computation without losing important information. And as such, we are just emphasizing why the weights are extremely important, but also here are some of the GATs that we have, the different categories and their applications. We shall come back to that. So, sparse attention mechanisms allow us to selectively focus on the most important edges. This reduces the number of computations while maintaining key information. and that's the reason why this exists. There is need to have that filtering to know what is the most important thing. Um, uh, Going forward, to efficiently process these sparse graphs, we use specialized sparse matrix operations, and here you can write your programs. So, for example, frameworks like PyTorch and TensorFlow provide built-in support for handling sparse tensors. And so, mm, once you have time, you can see how you can explore some of these libraries so that their uh, memory usage is efficient, and that's very important. Sparse GATs also have various real world applications, from social networks to biomedical research to molecular um, science to also brain uh, technology, understanding the brain. But you can also use it to develop uh, complex road networks that you cannot easily develop without using this. The ability to efficiently analyze large graphs makes them invaluable in AI research. So I just wanted to compare the GATs and then the sparse GATs so that you can see the compute power, the memory usage, the scalability, and accuracy. This comparison highlights how sparse GATs significantly reduce computation and memory usage while maintaining accuracy. So you can see, for example, a feature like the compute cost. When for the standard GAT it's high, the other it's lower. Memory usage is high for the standard GAT, but for the sparse GAT it is optimized, so it because of the filter network. Then the scalability, it's limited under the standard GAT, but with the sparse GAT there is a lot of scalability. And then the accuracy, they are almost the same. They both have high accuracy. Yes, and it is important to note that so that you know the difference between the GATs and then the sparse GATs. So, in summary, sparse GATs are a crucial advancement in scalable graph learning, and we are still learning more. Future research maybe should or will continue to refine sparsity. It will continue to refine sparsity techniques to further improve efficiency, because efficiency is what we are looking for. And probably research in quantum computing may help this out, but we look forward to what would happen. There are also a number of resources that we can check out. For example, there is a book, Sparsity, which talks about graph structures and algorithms. There was a lot of information on this, and there are a number of books, but I only just chose a few. And Velikovic. Then there are papers from ICML. There is the PyTorch that I earlier talked about, and then there are also some other courses that you can find on Coursera, on on uh, on lynda.com. There are a number of courses that you can use to enrich um, um, uh, you can use to enrich your knowledge in this area. And in brief, that is what I wanted to talk about GATS. And thank you for listening to me. If there are any questions, you can always get in touch with me. Thank you once again.